In this video, we're going to take a look at an introduction to circle theorems. Now, at GCSE Maths, there's a number of different circle theorems that you need to be familiar with, and hopefully, after watching this video, you'll be familiar with those circle theorems. Now, we're not going to cover any exam type questions in this video, we'll save that for the next video. So if you're looking for more kind of exam revision on circle theorems, be sure to check that video out instead. So let's begin with probably the easiest circle theorem that we've got, and that's angles in a semicircle. So the angle in a semicircle is 90 degrees. So what we're saying here is if we have a diameter like so this line here xz, and this goes through the center, so we know it's a diameter, and it touches these 2 points here on the circumference and goes through the center, so we know it's a diameter. If we've got this diameter here, then what we're saying is from the 2 points on the circumference, so let's do this in a different pen color just to highlight this. So from these 2 points here, so z and x, if we go up those lines here, and then go up this one here, so not perfect, I'm not doing it with a ruler, but this angle here that's formed is 90 degrees. Okay, so that's what we're saying here. So obviously you can use this for a number of different ways. So for example, you might be given, say, this angle here, that might be, say, 40. You won't obviously be given this angle here, but we should be aware of this circle theorem. So using this angle here as 40 degrees, knowing this one here is 90, then we could obviously work out the remaining angle. So that's just one type of example there why we might need to use that circle theorem. Okay, but like I said, probably the most straightforward circle theorem that we've got. Now, the next example here is taking a look at a cyclic quadrilateral. So what we're saying here is the opposite angles in a cyclic quadrilateral sum or add to 180 degrees. So if I've got this angle here, so xwz, so the angle xwz, and then the angle xyz, so plus the angle xyz, then they must add to 180 degrees. Okay, so if we pick two numbers here just to kind of see what this would be like, if we say this angle here is, say, 100 degrees, then this angle here must obviously be 180 minus 100, giving me 80 degrees there. Okay, so like you can see, that's how this rule works here. And clearly, the same holds for these other opposite angles here. So the angle WZY, so WZY plus the angle, so WXY, the angle WXY, again, they must add to 180 degrees. Okay, so that's the cyclic quadrilateral rule. And all we mean by a cyclic quadrilateral here is that we have a quadrilateral where all 4 points are lying on the circumference of the circle. Okay, so like you can see here where we're doing those points in red, all 4 points lie on the circle, and you'll be told that, or they lie on the circumference, sorry. So you'll be told that in the question. Okay, so that's the cyclic quadrilateral rule, or the cyclic quadrilateral theorem. The next one here is the same segment theorem. And what we're saying here is angles in the same segment are equal in value. So again, just using this red pen here just to highlight this. So for example, this angle here would be equal to this angle here. So using our notation here, the angle, say WXZ, would be equal to the angle ZYW. Okay, so ZYW. So if this was, say, I don't know, 50 degrees, then this too would be 50 degrees. And clearly this also holds for the angles at the bottom in the same segment. So this angle here will be equal to this angle here. And again, if we just pick two examples, if that's 35 degrees, then that too must be 35 degrees. Okay, so again, we use this notation, the angle XWY, so XWY must be equal to the angle of YZX, so YZX there. Okay, so like you see, we've highlighted that with the different colors. So like I said, these two red angles are equal, same for these two angles here. Okay, so angles in the same segment are equal in value. This next one here is the angle at the circumference theorem. So what we're saying here is the angle at the center is twice the size of the angle at the circumference. So we do this with a different pen color again. So what we're saying is this angle here, say this is x, okay, x degrees, for example, then this angle here is double that. So if this is x degrees, then this would be 2x degrees, okay? If we use actual numbers here, so if we just get rid of these examples, so if I pick, say, I don't know, 40 degrees here, then this would be 80 degrees. If this was 50 degrees, then like you can see, this would be 100 degrees. If it was 60, this would be 120, and so on. So it's always just double, okay? Now, whenever you see this kind of arrow shape, this is like how I like to kind of think about it, this arrow shape here. If you see that arrow shape, there's a good chance that this theorem will be involved, okay? So be aware of that. The arrow shape is a good clue that you're probably going to need the angle at circumference theorem. And moving on to the very last theorem here, what we've got is probably the trickiest theorem, especially to kind of spot here, and this is the alternate segment theorem. Now, it's quite tricky to understand from the definition, so what we'll do is we'll draw it on in a moment. So what we're saying here is the angle that lies between a tangent. So what we've got here is this tangent at the bottom, okay? So the angle that lies between a tangent and a chord is equal to the angle subtended. And we've not really discussed this word here, subtended, but this just means, it's just a kind of a posh mathematical way of saying made. So the angle that's made by the same chord in the alternate segment. So what I'm actually saying here is this angle here, so this is between my tangent and my chord, that's equal to the angle subtended by the same chord in the alternate segment. So what we're saying is this angle here, let's say that's, I don't know, 50 degrees. And this angle here is also 50 degrees, okay? And we can also apply that. So again, let's use a different pen color here. Let's use orange. This angle here, again, between the tangent and my chord, or our chord here, let's say this one is 60 degrees, and that's equal to this angle here, okay? That 2 would be 60 degrees. If that was 70, that would be 70. If this angle here was 30, then that would be 30, okay? So like you can see, that's how the alternate segment theorem works. I know some people like to kind of draw this on with colors, so you might go down this angle here, and then, oops, I'll try that again. I didn't do a very good job there. So if we go down the chord here, and then go up this chord here, then it leads you to this angle here. Do the same with the red angle. Again, you can go down this chord, and then go up this one here, and it leads you to this angle. That's how some people like to remember it. It's completely up to you, but as long as you can remember, that's the alternate segment theorem, okay? Now, those are the main circle theorems that we need for GCSE maths. And sometimes what you might see, so we'll see this in the next video, is sometimes you might need multiple of these theorems, or might need to use multiple of these theorems in one question. And that's where things can get quite tricky. So this was more of an introduction to the circle theorems. Like I said, in the next video, we're going to take a look at exam type questions for the circle theorem. Or on circle theorems, word it a bit better. But there we go. So that brings us to the end of this video. Thanks for watching.